All right, hello everyone. Thank you for joining, and we'll be starting very soon. This session in this slot will be troubleshooting common SSDT errors. My name is Eitan Blumin. What you're watching right now is a recording as part of the Data Platform Virtual Summit. While this is a recording, I am still available right here. Look, no hands. I'm writing something in the chat room, maybe. And I'll be available here to answer any questions that you may have, and I'll do my best to help as needed. Let me go ahead and place myself right here at the bottom. So first of all, a few words about me. As I said, my name is Eitan Blumin. I am a DBA team leader and a senior SQL Server consultant working for Modern Data Solutions, which is the leading consulting company in Israel for the Microsoft Data Platform. We have our website right here, and I also have my own website with a blog at eitanblumin.com. You can see my Twitter handle and my LinkedIn profile on the screen. And I also co-host the SQL Server Radio podcast together with Guy Glanzer, who is also from Modern Data Solutions. I'm a Microsoft Data Platform MVP since the year 2020, and I myself have been working with SQL Server and the Microsoft Data Platform since the year 2005. So you can say I'm a senior consultant, maybe. Yeah, I know my stuff. So anyways. Right, so what is this session about and who is the for? The session today is, its long title is Troubleshooting, Build and Deployment of SSDT Project for SQL Server DevOps. What is this about? Who is it for? So it is for people who are already familiar, first of all, with the methodology and the terminology rather of the world of DevOps and CI/CD and SSDT. It is for people who already started working with SSDT, developing and possibly even trying to do automated deployments, and now they are encountering all kinds of issues and errors or possibly edge cases that they do not know how to handle or what would be the best way to handle them. So I, as a senior consultant, have a lot of experience consulting and advising companies in real-world scenarios for how to deal with such issues exactly. And I figured it could be a good opportunity to share this knowledge with you guys and possibly, give something back to the community. Okay, so let's look at our agenda for this session. So first of all, I would like to focus on preventative guidelines or methodologies when approaching development while keeping a deployment-aware mindset. We'll see what it means in just a bit. Next, we will see common build issues that usually come up when you start working with SSDT. Then we will focus on cross-database dependencies and database references, what you could and should be doing with them. And then we will see several common edge cases that are not always very straightforward in terms of how you should be tackling them. And then, hopefully, with enough time, I will look into how to troubleshoot SSDT deployments. Right, so starting with the deployment-aware development is how I call it. It is when you have the mindset during the development stage where you are aware that whatever changes you are doing, they are going to be deployed to a live database. And there are precautions that you would need to be taking as a result of that. So first of all, first and foremost, very important guideline is to have incremental schema changes. The idea here is that you would not be making any significant changes that could potentially risk data loss. For example, dropping a table, dropping a column, and would also avoid breaking previous functionality, for example, changing the parameters of a store procedure, of an existing store procedure, because let's say you have another store procedure that could have dependencies on that existing store procedure, and if you change something significantly in the parameters, that could break functionality of that other store procedure. It could also break functionality at the application level. Because it could be expecting a specific set of parameters or a specific structure of a table. So while developing, you need to do this with this in mind, which means making incremental changes, small changes, which you could deploy while maintaining, let's say, backward compatibility. Okay, that's essentially the idea. Next, you should also know about feature toggles. It is possible to make developments in SQL Server databases, as in any database, where you would have optional changes, optional features in your code, and we will talk about that in depth in a bit. And next, you should always strive to build trust for your project, or rather the artifact of your project, the DACPAC file. Essentially, you should build trust over it by repetition, basically. And what I mean by that is whatever it is that comes out of having a DevOps methodology, of having a development and test environments, QA environments, staging environments, user acceptance test environments, which is essentially like public or private alpha, beta, preview versions, and so on. At the bottom of the screen, you should see a link to a session by Alex Yates. I strongly recommend you watch it. It's a very useful session about zero downtime database deployments. It talks about a multitude of methodologies and best practices and methods of deploying database changes with zero downtime. It's very useful. I strongly recommend it. Watch it after this one, right? So let's focus on incremental schema changes. First of all, when you make a change to your schema, you could do it by expanding your existing schema, and only at a later deployment you contract the changes. For example, if you want to change the data type of an existing column, which could result in potential data loss, or maybe the functionality of the column of an existing column changes, or maybe you need to replace an existing set of columns with a different set of columns. So instead of doing the entire change in one version, one deployment, you would first deploy and expand. You would first expand your existing functionality, basically add additional columns that would be working side by side with the old ones. Okay? And then when you deploy this change, you would have a backward compatible version that would be able to serve both the old functionality of the system as well as the new one. And at a later phase, when you basically phase out the old data, the old structure, the old functionalities, when you're sure that nothing is using your old structures and has dependencies on them, then you can feel free to contract to reduce the size of your schema, and by removing all of the unnecessary columns, the old structures, and so on. Speaking of columns, when you add new columns, it is important to always add them at the end of the table, because if you add a new column at the middle of the list of a table's columns, it will cause the recreation of the table. It will create an entirely new table and with a temporary name, copy the existing data over it, and then rename the objects, drop the existing table, the old table. if you have a large table that, and maybe if it has a lot of dependencies, this could have severe consequences during deployment time, which you do not want. So always add new columns at the end of the list of the columns list of your table, to avoid this recreation of the table. Also, when you add new columns, they should always be nullable or with a default value. Otherwise, if you add a new column which is not nullable and it doesn't have a default value, that your deployment would fail, because you cannot do something like this. You need to take into consideration the fact that you have already existing data in this table, and something needs to be done with the existing data. In case of store procedures, you need to maintain the order of existing parameters. And also when you add new parameters, similarly to how you would add new table columns, you should add new parameters at the end of the list, so that you would not break any existing functionality that depends on the old structure, the old order of the columns. And also any new column that you add must have a default value, must have. Okay? Otherwise you risk breaking previous functionality. In case of function, it's a bit more complicated because the headers, and when I say header of a function, it means this list of parameters that it returns and the value that it returns, the data type, they need to be the same. Okay? But what if, for example, you need to deploy a change to a function that requires adding a new parameter? So in order to avoid breaking existing functionality that could depend on this new function, you should create a new function, basically. Okay, this is similar to like the expand and contract. Okay, so instead of replacing existing function, you add a new function with the new parameters, right? And maybe in a later version, when you are absolutely 100% certain that the old function is no longer in use, then you can drop it or replace it or rename it, or maybe not rename it, that's a bit risky, but you can drop it and leave with just the new function. Next, when you rename objects and columns or you change object schemas, you should always be using the refactor tool. That is its purpose. That is what it is made for. And if you do not do that, that means that, for example, when you rename a column and you deploy this change to production, that means that during deployment, the DACPAC will consider the fact that it has an existing column at the target, which doesn't exist at the source, at the DACPAC, and also there is a new column which doesn't exist at the target. So it would want to drop the old column and add the new one. It doesn't know that it's the same column. But using the refactor tool, you can do this properly. It saves like a sort of an XML metadata with information about the rename, and it will do so in a smart way. It will be aware that this is indeed the same column, and then instead of dropping and adding a new column, it will simply use the SP rename store procedure. Similarly, changes schemas of objects. If you do this properly using the refactor tool, then you will not risk dropping an existing table and adding a new one. It will simply use the proper syntax of transferring an object from one schema to another. Next, let's talk about feature toggles. So feature toggles is basically when inside your existing store procedure you have like a parameter of sorts, or maybe a variable, a local variable that defines the functionality of a store procedure. For example, let's say you have a store procedure called main procedure 1, right? and it has an optional parameter called new feature enable. This could also be a local variable inside the store procedure. It doesn't really matter. But inside the body of the store procedure, you have something like this if, which basically implements a sort of a branch in the logic, where when this feature is enabled, it executes a new store procedure, and when it is not enabled, it will execute an old version of a store procedure and another store procedure. It doesn't necessarily have to be a different store procedure. It could also be, the code blocks themselves inside the if. But due to performance considerations and compilations and execution plans, if it's something significant, like a significant difference between enabling or not the new feature, then it should be separate store procedure. Okay? You could also have something called percent toggle, or maybe a canary release toggle, which basically means that you enable the feature for a random percentage of people, or rather a random sample of users. So let's say, for example, 30% of the time you want to enable the feature. Okay, this could be like similar to A/B testing maybe, but you have a more explicit control over it, where you want to test the impact of a new feature. So this is an idea, a concept which is common in the world of software development, but there's no real reason why it wouldn't be used in the world of database development as well. So it's a useful method to have like a sample of, okay, what is the impact of this new feature that I'm doing. You could also consider whether this feature toggle that you are implementing is either code driven or data driven, which means you could either have it as a parameter or a local variable in your code, which makes it code driven, or you can store it like in a table of sorts, a table of parameters, a table of feature toggles, a table of settings that are either enabled or disabled. And then it could be easier to maybe change these values during runtime in live production without having to make any code changes or deploy new versions of your schema and so on. So for your consideration, just be aware of these methodologies. Let's talk about common build issues. First of all, the most common build issue in SSDT is object reference errors, which is basically when you have a store procedure that references objects which are either outside of the database or they simply no longer exist. When you first create your first SSDT project, which the schema of which is already an existing live database, most likely you would have such issues unless you have a very, very clean development methodology and so on. A most common issue that you would have is when, for example, you have dependency in one database for a dependency to another database. For example, you have three-part names in your store procedure or views or whatever it is, and now you need to replace all of the database names with their database reference names. Okay, it's not the same thing. I'll talk a bit about database references in the next slide, but for now, it is recommended when you have inter-database dependencies to add all of the involved databases as projects to your SSDT solution. You will have a solution with multiple SSDT projects, and they will have references to each other. Okay, it's important that they would be in the same solution. They would have the same .NET framework version and the same database compatibility. Okay, you can change all of these things in the project settings. And if all of these things, something was changed, like the framework version or the database compatibility was changed, sometimes, not always, sometimes you would need to drop and recreate these database references in order for the build to work okay. Next, you could also have unsupported object types in your SSDT project. For example, you will have static data or lookup data, which I recommend using sp-generate merge and copy pasting it into your post-deployment script. In SSDT, you have pre-deployment script and post-deployment script, which are very useful for implementing source control of objects which are not natively supported by SSDT, such as data or such as SQL agent jobs. Okay, there's also a link here to let's see if I can show you the tooltip. Yeah, right. There's a GitHub repository at Avolok called AZDO SQL Server DBA. It's a set of tables and store procedures and functionalities that allow you to store source control for SQL agent jobs. You could also use, the native creation scripts that you could generate using SSMS for SQL Server agent jobs and envelop those in an existence check. As in, if the job doesn't exist in msdb.dbo.sysjobs, then create the job, right? You should also remember to pay attention to the job owner. Okay, when you create a new job, by default, it is created with its owner as the current user. Okay, sometimes you would need to explicitly set a specific owner for these jobs. Maybe it's an SA or SA equivalent, as in maybe SA was renamed, or maybe a specific login that you have that should be the owner of jobs. Obviously, this login needs to exist in the SQL Server instance. So all of these things need to come into consideration. Don't forget about them. Speaking of database dependencies or database references, so we have three levels of database dependencies references in SSDT. One is cross database reference, which is a three-part name, which is basically means a different database, same server, and it looks like this. Notice that if you have a database named OtherDB, let's say in your environment, and you have code that depends on this other database, you would have to go through each such module, such procedure or function or view with the dependency on the other database and change it to be using the equivalent SQL CMD variable, which is the one with the $sign and the parentheses. You could use, because it's a Visual Studio project, you could use find and replace quite easily to find and replace all other DB dot instances to dollar parentheses other DB dot. Okay, use the power of Visual Studio to your advantage for this. Okay, the same is true about cross-instance references, which is, for example, if you have a linked server, so you have both the server name and the database name as part of the reference here, and they both have a SQL CMD variable, right? Also, if you have self-referencing modules, as in modules that reference the database itself, the local database, you could either replace them with something like this, the $sign parenthesis database name. This is a built-in SQL CMD variable. Okay, it's built-in. It is natively it exists in your SSDT project. You can use it for various purposes, including for these self-reference three-part name references. However, as a best practice, I would rather recommend just removing this. Okay, you would rather use two-part names when referencing objects within the same database. Okay. And finally, if you have dependencies on system objects, system DMVs, system views, and so on, you would need to add references to a system database. okay, which is either master or MSDP, depending on the context. Sorry, that was a misclick. And then you would have proper references to those objects. SSDT will recognize them, and the build will go okay. Now let's talk about those edge cases that I mentioned earlier. So the first one is replication. What if you have replication and you have a subscriber and a publisher? Where do you save the objects? Okay, so my guideline is to always maintain a single source of truth. If you have an object which is replicated from one publisher, let's say, to a subscriber, that means that this publisher is the single source of truth for this object. And if its structure changes, those changes would be automatically deployed to will be replicated rather to the subscriber as well. I would recommend to have both the subscriber and the publisher in your SSDT solution, in your Visual Studio solution as SSDT projects with the direct references between each other. You could do it using same database reference, as in the subscriber would see all of the objects of the publisher and would consider them to be within the same database, so that you would not need to reference them using three-part names. Okay, this is you can do it using same database reference. However, let's say you have the objects that are replicated from the publisher to the subscriber. It's not all of the objects. Maybe it's a small subset of tables, so just maybe a few tables, and you don't really need to have all of the publisher database as within the same context of the subscriber database. So what you could do is create a third project, okay, like a middleman project, which would have only the replicated objects, and this one would be the single source of truth, okay? And then both the publisher and the subscriber would have same database references to this replicated objects project, the third project, okay? It's a bit more difficult to manage this, okay? But it would result in cleaner code and cleaner deployment, okay? And when you deploy these changes, you will need to deploy first the publisher database project, and then on top of it, you will need to deploy the third project, the replicated objects project, okay? And when you deploy the changes to your subscriber database, you will need to deploy first the subscriber database project, and on top of it, you deploy the replicated objects project, okay? You could also, alternatively, instead, okay, this is instead of a database reference, you could also add as link the file which exists at the publisher. For example, if you have a table that is replicated, you could add an existing item, okay? In the subscriber project, you add an existing item, and you find the file, the existing file that already existed in the publisher project, and you click on the little arrow over here and choose Add as Link. What this does, what this is doing is it tells Visual Studio to not physically take the existing file itself, but just add a link, like a virtual link to the existing file, and then you only have one instance of the actual file. But in Visual Studio, it shows as if the same file exists in both projects. Okay, this is very useful for replication, for replicated objects, because you don't need to mess around with database references that could have other issues, and it makes deployment much easier, much simpler, and also maintains a single source of truth, because the actual physical file, the actual physical file exists only in one place. And when you change it in this one place, it automatically affects all of those dependent on it. You can still create subscriber-specific objects. For example, indexes that exist in the subscriber, but not in the publisher. You can still do that. That's not a problem, because as long as the subscriber is aware of this the replicated table, you can create the additional objects as separate SQL scripts. Okay, separate SQL scripts that exist only in the subscriber, not a problem. Right, so let's talk about cyclical database references. This is a dangerous issue. If you have cross-database references, it's a complicated issue. If you have cross-database references, one database depends on objects in another database, and the other database also depends on objects in the first database. You cannot do this at all in Visual Studio. It will not let you create these references, because Visual Studio does not allow cyclical dependencies between projects. The way to resolve this would be a bit complicated, okay? But the general idea is to split to separate these database projects to modular database projects. As in, let's say we take in DB2 the purple database here, we take out of it all of the objects that depend on DB1, and we place them in a third project, okay? And that third project would have same database reference to DB2, okay? And it will also have cross-database reference to DB1. DB1, on the other hand, would have database reference on DB2, but not to the dependencies project, the third project with the dependencies, right? And this prevents the cyclical dependencies. Both the build and deploy order in this case would be DB2, which would not contain objects which depend on DB1, okay? And then you deploy DB1, which does have dependencies on DB2, okay? And then you would deploy the DB2 dependencies project, which has dependencies on both the databases, okay? It's a bit complicated, I know, but it does solve the problem. Next, let's talk about SQL CLR. So, as you should know, there is a trustworthy database setting in SQL Server, which basically means that you can create any level of you can create CLR assembly within database with any level of permissions, whether it is safe, unsafe, or external access. There are risks to this. It is strongly recommended not to enable this flag. So there are proper ways to deploy SQL CLR assemblies without setting this flag to be on. Okay. Additionally, you also need to take into consideration that you need to have CLR enabled in the instance setting at the target SQL Server instance where you deploy your project. And in SQL Server 2019, you also have a new setting called CLR strict security, which basically means that even safe assemblies, they still have strict requirements for deployment. Okay. What are these strict requirements? What am I talking about? I'm talking about, of course, digital code signing. Okay, which basically means that you have some kind of digital signature on your assembly. This digital signature comes in the form of a private and public key, of an asymmetric encryption key, right? And basically, what you need is for the SQL Server to recognize this key, this encryption key, and be aware that this specific key, which is, you could also call it a thumbprint, like a thumbprint for a key. It is allowed. We explicitly granted it the permission to create an assembly with either an unsafe external access or safe safe permissions level, right? So how you would do it, you create a master key in your master database. You create an asymmetric key whose source is the DLL file, the already compiled DLL file of your assembly, of your basically the DACPack project, the SSDT project, and then you create a login from this asymmetric key, and then you grant the required permissions to this login. And then what happens is when during deployment, the DACPack SQL Server checks the thumbprint of the assembly. It checks for an existing key and a login with this that belongs to this thumbprint that maps to this thumbprint, and it checks whether it has the proper permissions. That is all. At the bottom of the screen, you can see a link to a script, an example script that you can use as a pre-deployment script in your SSDT project, which basically does everything I said before the deployment, the actual deployment of the project even begins. Okay, there is a tricky part there because you need a DLL for this key to be created, which is a bit of a chicken and the egg here. But all you need to do is to be aware of the location of the DLL file. Okay, as long as you know what is going to be the location of the DLL file, you can go ahead and run this thing. Let's talk about partition functions and schemas. What if you have partitioning in your database and you deploy it using default settings? And what will happen is that your partitions, your new partitions will be deleted. Other partitions might be too old will be created, and you will have a whole mess. Okay, and it would risk even failing the deployment because of all the data movement involved. To fix that, all you have to do is either use a publish profile or a parameter during deployment, which says ignore table partition schemes. Okay, you can also add ignore table partition options, but the important one is this one: ignore partition schemes, which means that whether differences in partition schemes and functions should be ignored or updated when you publish to a database. This basically means the partition ranges. Okay, so you have a sliding window. You need to use this. It's recommended to use publish profiles for this. Okay, and save these published profiles as part of your source control in your SSDT project, and then you can reuse them very easily. Right, so moving on. Let's talk about troubleshooting SSDT deployments. First of all, the publish script. So when you use SQL package utility, which is the one used for deploying DACPack artifacts, you can use an action script, action:*script, which basically means that the publish script, the change script, would be generated, but the deployment itself would not be performed. So this way you are able to review in advance the script that would be run if you had run the deployment, the whole shebang, right? Fully. You could review it, and then you would be sure that you are that it includes what you expect it to include. This is something I recommend using, especially the first times that you perform a deployment, just so that you would be familiarized to familiarize yourself with it, and to make sure that the changes you made during development cause expected changes in during the actual deployment, right? There is also something called a deployment report, which is an XML file that you can generate during deployment, which has like a report of which objects are affected and how, the kind of impact that they would have. So again, to make sure that you have an expected result here. You could also use PowerShell. I personally recommend using DBA tools for this purpose, to generate both the database script and the deployment, the script, the publish script, as well as the deployment report. You can see on the screen an example for a code that does this using the publish DBA DAC package commandlet. Okay. At the bottom of the screen, you can see a link to our. Sorry, let me just move my face away from here. Right. At the bottom of the screen, you can see a link to our GitHub repository with an example PowerShell script that performs deployments using DBA tools. Okay. You can go ahead and peruse it and use it as an example or as a starting point to develop your own deployment script. In general, when you fear the result of your SSDT deployments, I would recommend basically shallow waters, baby steps. Okay, start with shallow waters, take it slowly, baby steps. What I mean by that is when you first deploy your first time SSDT project, start with local, as in your local host, your local installation of SQL Server on your personal workstation. If you are a respectable SQL developer, you should have such an instance on your workstation. Start there, okay? It's very basic, just to make sure it's like treated as a sort of a sanity test, okay? To make sure that just the basic things work okay. And next, before you're ready to deploy to production, to an actual live server, start with manual. Don't do it automatically right off the bat, okay? Unless you're very confident in your abilities. If you're not, that's fine. Start with manual deployment, either using PowerShell or command line. Start with script, start with deployment report, slowly, okay? Baby steps. And then when you feel confident enough that your deployments work okay as expected, then you can graduate later to automated deployment, which is what we want. You should also be familiar with dynamic SQL CMD deployments, which basically means, let's say that in one deployment you want a certain set of changes to be done, and in another deployment you don't want them to happen. Okay, so you could do that using SQL CMD variables. Let's say that you have in one environment you need to create jobs. Okay, so you have, but in another environment you don't. So you have a SQL CMD variable that during one deployment will be set to true, and then say in your post-deployment script you would have something like this, and this would check whether the value of this SQL CMD variable evaluates to true. If it is, then execute the other script that contains all the job creations. Okay. Also, maybe you have all kinds of data changes that need to be done as part of a specific version or in a specific environment. So you could use that as well, similarly. Okay, in an if statement, and if only if it evaluates true, then you execute the contents of another post-deployment script. You could also have something that I call dynamic idempotent deployments, which means if you have a need as part of a certain version deployment, you need to make some kind of change in your data, which is something that you can't basically save natively as part of your source control. You can't save data natively. You need to have post-deployment script, basically implement these things yourself, right? But what if these data changes are relevant to only specific versions? And once you run them during that version, you don't want them to be done again in next versions. So something that I like to use is basically like a temporary table that will contain these commands, those SQL commands that make the necessary change, and then you would version these commands, okay, or basically just number them, okay, and then you would run through them using a cursor. and just execute them. But you need to save somewhere the last version, the ID of the number of the last change that you made. You need to save it in some kind of table in your database, so that you would know that the next time this thing runs, you don't need to run this command again. So I like this method very much. It basically means that each command here executes once. It is data driven, which I like very much. It requires a minimum number of objects to create specifically for this purpose. In this case, just this one versioning table. Okay. It is very easy to maintain because you can save this script as a post-deployment script in your project, and then whenever there is a new change that needs to be added, then you just edit the script and add it as a command in the values constructor over here, right here. Okay, and it's also easy to track because as a post-deployment script, it exists in your source control, and you can easily track changes. With all of that being said, there are still abnormal deployment use cases that could be possible. Okay, where and what I mean by that is where the manual migration script, the effort necessary to manually make this change would be much simpler instead of working around SSDT limitations, such as unsupported objects or unsupported operations, or maybe something that simply requires too much work. Okay, it is okay. That it's acceptable. It's okay because SSDT is a state-based deployment. That means that if you make this change, this abnormal edge case change, manually in your production environment, but also make the same change in SSDT, and when I say make the same change in SSDT, I mean you end up with the same desired end state in your SSDT project, okay, as a result of this change, whatever it is. And then during deployment, because it is state-based deployment, a comparison, schema comparison would be done. It will see that it has the exact same desired end state, and no change will be done as part of the deployment, not as part of the automated deployment, okay? So again, you can make complex changes directly to production manually. You apply the same desired end state to your SSDT. It will be saved in source control. There will be a CI/CD pipeline, but it would have no effect because the desired end state already exists in production. Okay? Now, this is something that will be relevant for abnormal edge cases. Okay? It would be rare for you to be doing this. Common daily development, I will still say that SSDT is still ideal for it. Okay, common day-to-day development, you should use SSDT for it. Using the native functionalities. Anyways, if you want to learn more about database deployments, I strongly recommend checking out Alex Yates' session about zero downtime database deployment. You can also see on the screen the GitHub links to the resources that we mentioned in this session, such as Generate SQL Merge, AZDO SQL Server DBA, and also the scripts from our own Modera Data Toolbox repository. Also check out DBA Tools for the command to publish duck packs. And also check out the Microsoft Docs section about project-oriented offline database development. It's basically best practice for how to work with SSDT during development. And also more information about the SQL package utility itself, the parameters and properties that you can play around with. Very useful to be familiar with this. Anyways, thank you for having me in this session. Now it would be the time for questions, and I would be available answer them in the chat. And that's it. And also special thanks to Microsoft for supporting Data Platform Gigs and SQL Server Gigs and making this virtual summit possible. There are 3 ways to win prizes. You can post your selfie with the hashtag DPS 2022. Please provide feedback to the sessions and the speakers, and check out our sponsors and exhibitors, and follow Data Geeks on Twitter and also Data AI Summit. And that's it. Enjoy the rest of the summit.